Good morning, everybody. Thanks for coming to my keynote, and thanks, Jeff, for the really nice introduction. My talk is titled, Why We Are Not Building a Defendable Internet, and the not needs to be underlined here. And it's a bit of a strange way of approaching, or perhaps a strange title for a talk, but it is a sequel to another talk I gave last fall in Amsterdam called Building a Defendable Internet. And in the talk in Amsterdam, I focused on, well, what would we need to do on the technical side to have computing devices that we can actually meaningfully defend against attackers. And the talk in Amsterdam was entirely focused on the technical changes and intentionally omitted all the political and organizational and otherwise obstacles that are in the way of building devices that we can meaningfully defend. And I always joke that all offensive problems are technical problems and all defensive problems are political problems. So by me skirting the entire topic of organization and politics and incentives in the talk in Amsterdam, I pretty much skipped all the difficult things back then. And this talk today is going to be, well, about all the problems that are not technical that stop us from actually having defendable devices. So the talk in Amsterdam argued that we should build devices that we are capable of defending. And in order to be capable of defending, we need to be able to identify compromise in the first place. Because for pretty much any device these days, I have no way of deterministically saying nobody has compromised this device. I usually do not have the introspection capability of taking the device and saying, at this point in time, it is not compromised by anybody else. So the argument in the technical talk was, we should be building devices that allow us to enumerate all persistent code on the device and to display a hash of everything that can run on the device, including all firmware, including everything, and also that allows us to reset the entire device to factory defaults. This would need to be coupled with a public inspectable ledger where everybody that writes software, firmware manufacturers, software manufacturers, place their software publicly visible to avow that they have actually written the software and they stand by the software as it is. And then the part that actually hashes and displays would need to be hardware and would need to be non-updatable. So an attacker that compromises the device has no way of messing with the integrity checking. That's the technical side of it. And if we had devices like this, we would be able to diagnose for a given device, is this currently compromised? We would be able to diagnose for code signing and other PKIs whether the signing keys have been stolen, which is something that we can't properly diagnose today, but it happens all the time. And we would have much cheaper cost of remediation because we could say, well, we've had an incident, these 100 machines here were compromised, can we all reset them just into factory defaults using the hardware switch that is on the device? And interestingly, given the scale of device manufacturing and given the changes that are needed, the actual production cost per device to add all these things would be on the order of perhaps $1 per device, which is not that much. It may be too much for IoT devices, but for something like a smartphone that retails at a couple $100, that shouldn't be too much. So the big question then becomes, why don't we have this? And in order to discuss why we can't have these things, we'll talk about who are the different actors that we need to consider when we look at, well, the IT infrastructure market. What are their individual incentives? And how much power do they have to enforce changes that they would like? And yeah, it may not be the most optimistic talk ever. So we've got this diagram here. On the top left, you've got the enterprise customer that wants to build IT. And he wants to use this IT to provide services to the customers at the bottom left. In order to provide services to the customer at the bottom left, he goes to the top right, to the software vendors, to the system integrators, and to the hardware vendors, and purchases stuff and services from them. And now he needs to somehow manage risk. And in order to manage risk, he hires a CISO. And the CISO then provides services to the enterprise, the service of managing the IT risk. And the CISO, in order to do this, usually makes use of the internal security organization that he heads, of third-party security vendors, and which is the new kid on the block of cyber insurance. And this is roughly a very, very coarse approximation of how things look in the real world. Now, the enterprise buys software and hardware, and the CISO gets tasked with managing the risk, oftentimes, unfortunately, after the fact that the hardware and the software has been bought. Sometimes he has sufficient impact or influence to actually influence the purchasing decision ahead of time. But this is the basic setup. Now, in an idealized scenario, in a perfect world, from the perspective of the CISO would sit down with the security organizations, with his technical staff, with his experts, and they would start deciding on security requirements. What would we need in order to defend our enterprise? What would we need to manage the risk for our enterprise? And then in the ideal world, they would just communicate this to the bigger organization, and the bigger organization would tell the suppliers, would tell the software vendors, the system integrators, and the hardware vendors, so in order to manage our IT risk, we need computing systems that do X, Y, and Z, and these are the security properties that we would like, and now please go and provide us with what we need. So in this idealized world, the hardware vendors and system integrators and software vendors would then find out how they can all build a system that satisfies the need of the enterprise in terms of security. Now, everybody in the audience looks at me like I'm crazy, because this is really not reality. Like, this is not how IT purchasing works in any way, shape, or form. The reality is that software vendors and the entire supply side for IT is insanely scale-driven. Meaning we do not have many suppliers of CPUs. We've got Intel, we've got ARM, and we've got AMD, partially as virtue of Intel not allowing AMD to die because they need a competitor, otherwise there's antitrust issues. So the reality is that on the supply side, we have these huge oligopolies which supply pretty much everything. How many different vendors of hard disks are there? 3, 4? I don't know. How many different vendors of Wi-Fi stacks are there? 3. How many different vendors of enterprise-grade server CPUs are there? 1. And so forth. So we've got these massive conglomerates on one side that really are all about scale, and the enterprise really has little market power. There's very, very few companies that can go to Intel and say, we would like to have this change. And when I say very few companies, I essentially mean none. If you look at something like Intel's management engine, I have yet to meet a single enterprise that doesn't hate the idea of having Intel have that management engine everywhere. But there's nobody that has sufficient market power to say, well, we'll go to a competitor. Let's assume for a second you have a big search engine and you buy a lot of CPUs, and you wouldn't want management engine inside your CPUs. You go to Intel, you say, well, I'm going to take my business elsewhere, and Intel will say, where? Right? So realistically, most enterprises buy their hardware and their software from suppliers where they have very little choice of changes and very little input in the design process. And if the enterprises already have very little input into the product design, then the CISO has even less. So the reality is that the CISO and the security org, they can sit down and write requirements what they need all day long. They literally have, as an individual CISO, as an individual enterprise, insufficient market power to enforce any changes on the supplier side. So let's say I would like to have a hard disk where I can inspect the firmware. Nobody buys enough hard disks from one hard disk vendor to actually make the hard disk vendor add 50 cents worth of hardware to the hard disks in order to allow this. So the reality is almost no enterprise has any meaningful influence on shaping what they buy and deploy in their IT, and therefore they can't make any security requirements. So in a way, the CISO and the IT security teams, they would like to buy secure and more easily defendable products, but there are none on the market and they can't really get any. And now, in a way, we have a stopgap solution. If we can't get what we actually want, there's an industry to sell us an approximation of what we would like to have, which means we have the security vendors and the cyber insurance people that recognize that we can't actually get what we want, so they'll sell us something else, but they'll sell us something. The important thing to remember is that both the security products industry and the cyber insurance industry, in a way, is an attempt to fill a gap. The gap being the ability to actually shape the stuff that we deploy. So let's examine security vendors first. Security products not all of them, but a large fraction of them are a very puzzling thing to look at, because most experienced security practitioners know that most security products, especially enterprise security products, combine two very undesirable features. They usually combine the feature of being trivial to bypass by an attacker that does any form of quality assurance, and they combine this with a lot of highly privileged attack surface. The majority of antivirus software runs a lot of 1990s C code at root privilege on your machine, scanning every mail attachment. Like, anybody who knows anything about how you should architect software sees that this is a really bad idea. But why are these products there if they are such obviously bad ideas? So there's got to be somebody who wins from them being there. So it's quite puzzling. Why is there a market for products where most experts agree that they're not actually all that useful? Now, secure products, actually secure and defendable systems, would reduce the risk of the enterprise and therefore of the CISO as well, because he's getting paid to reduce the risk. Now, the funny thing about security products is they may not actually help all that much, but they look as if they could plausibly reduce the risk of the enterprise. And by looking plausible, they reduce the risk of the CISO. So, in a way, the CISO is in the annoying situation that he gets paid to manage the IT risk, but what he would actually need to buy isn't on the market. He can't buy secure devices, but he needs to do something. So the biggest risk to the CISO, to a certain extent, is being seen as having missed an important risk. You're being paid to manage risks. If something goes bad and you've forgotten that particular risk, then that's your fault. Whereas if you haven't forgotten the risk, if you've bought a product and the product fails to stop it, well, then at least it's not your fault, right? So the reality is that if you look at IT security purchasing decisions, a lot of CISOs know that there's not many good products on the market, and they often can't differentiate between the different products. So a lot of enterprises have this strange strategy of portfolio purchase. We'll just buy one of every product category. We'll buy one IDS, we'll buy an AV gateway, we'll buy a data loss prevention thing, and just buy one of each product category, and then you've at least shown that you've seen all the risks. And whether an individual product actually fails or doesn't fail, that's a secondary issue, really. So in a way, the purpose of a lot of IT security products is sadly to limit the risk to the CISO, because the CISO can't really lower the risk for the enterprise. So the actual functionality of these products is kind of secondary. Like, whether they perform well or not in the face of an adversary doesn't matter. The product mainly needs to look like a reasonable choice. It needs to have the right checkboxes. It needs to look as if a reasonable, smart person could reasonably think that this could work. So the result of this is we have a market full of security products that will fail if an attacker tries to actually do QA against them. They only work by virtue of the attacker not testing against them. Dave Itelamy used to joke that the best security appliance is one that is sold exactly once and costs $2 million, because the attacker would need to buy that security appliance to do his QA. And the other thing that this leads to is a proliferation of new product categories where, if I want to grow my security products industry, I need to invent a new product category, and then portfolio purchasing on the buyer side will make sure I sell enough boxes. And the purchasing decisions of the individual devices are being made mostly on marketing and manageability. And there's no malice in this, right? It's perfectly rational for a CISO to be confronted with this big group of products that all kind of look similar, and if they all kind of look similar and if they're kind of indistinguishable, it is rational to buy the thing that is most manageable. It is rational to buy the thing that provides the nicest dashboard, because you can't actually compare them on anything else. So after we've looked at the security products field a little bit, the other big player that is entering now is cyber insurance. And cyber insurance is it's going to be a really interesting area. I moved to Zurich after I joined Google about 7 years ago, and Zurich is full of insurance and finance people. It's very enlightening to talk to these people because they have a very different view on things. So cyber insurance offers to mitigate the cost of breach to a certain extent, which means you sign up with your insurer, and the insurer will insure your cost of breach. They'll insure the cost of incident response usually, because As reporting requirements have grown, the cost of actually finding out what happened has grown as well. What they usually do not insure is reputational risk, as well as loss of user trust and so forth. And what they also do not insure is loss of critical IP. These things are usually not insured because they're so difficult to calculate, and also, well, they can be massive. So cyber insurance is fascinating to watch because you can see all the insurers stirring their feet and really wanting to get into this because they see there's a lot of money to be made. But it's very, very different from all the other things that they've normally insured. First of all, there's a real scarcity of historical data, meaning we have a lot of data about how often earthquakes occur, roughly. We have a lot of data about floods. We have a surprisingly small amount of data about bigger computer or cybersecurity incidents. The other part that is really difficult for insurances is the assumptions of a static distribution is violated. What I mean with a static distribution is in order to make inferences about the future from the past, you have to assume that the process that generates your data doesn't change. And this is just not true for attacks. Like attacks that happened 6 years ago may look quite different today than they looked 6 years ago. And what I found super, super interesting when having beers with one of these insurance people, he explained to me, well, the current strategy is we'll just underwrite without fully understanding the risk and without having the data. He more or less said that, well, we don't have any of that data, but we've set aside $1 billion here that we're willing to gamble. And this $1 billion will be used to underwrite cyber risks. And through the process of blindly underwriting risk, we will get the data because the people that we've insured will provide us with the data during the incidents. It's a very, very interesting approach. And I found that like the willingness to just set aside $1 billion as data acquisition cost in order to model stuff in the future, that's a bold strategy. So insurances, in theory, could be a game changer for security under certain assumptions. In theory, the insurances could obtain the expertise to actually compare security products and to tell good and secure products from bad products. And the insurances, in theory, could offer lower premiums to enterprises that deploy better products and that have a better infrastructure. So in a way that could change security from being a pure cost center to something where good security decisions actually make a difference to your cash flow now. Because the reality is security is a cost center all the time, and then something really bad blows up, and then security is still a cost center, just a spike in cost center. Whereas if there's differences in the premiums that insurers charge, good security decisions can have some sort of impact financially immediately by lowering premiums. The other thing that insurances, in theory, if everything goes right, could do is they could bundle market power. Because at the moment we have all these enterprises that may be big, they may be Fortune 500s, but as I mentioned, they don't actually have enough market power to influence product design. Whereas if insurances offer lower premiums for particular security properties in products, that bundles the marketing power, the market power, which means at that point you have all the F500s saying, well, our insurance tells us we can get lower premiums if we deploy X feature. So we would like X feature. Dear vendor, make this happen. So in an ideal world, insurances could bundle the fragmented purchasing power and lead to better products. Cyber risks are really difficult, though. First of all, very few insurances have sufficient expertise. Very few insurances have any sort of proper data. The other thing which makes computer incidents really difficult is that you have an underlying condition that is not diagnosed, that when it gets diagnosed, everybody that is affected gets rolled up, which means, let's say you've got a big APT campaign that has hacked, 20% of the Fortune 500. And they've been sitting in these networks for a few years, which is not an unreasonable assumption. Now, if this APT group gets rolled up, if they get caught, and if their toolchain gets burned, it is very likely that through sharing of threat intel data and so forth, they will get caught in many different enterprises at once. Which means for the insurances, you have what they call a cumulative risk, where a lot of risks will blow up at the same time. Insurances ideally want risks to be as independent from each other as possible for the statistical modeling. But the trouble with big incidents is you have all these things that are compromised, and when it blows up, it'll blow up everywhere at once. And then insurances have, well, a huge lump risk that they don't really like. Another thing is that the risks at the moment are huge because the way we've built our computing infrastructure, having a malware or having a sort of incident where the attacker builds non-disinfectable backdoors into the device, say flashes a new BIOS that refuses to be reflashed, then replace all computing devices in the enterprise is a possible outcome of an incident. So that can get expensive very quickly. Another thing that we have to remind ourselves of is IT is growing exponentially and has been growing exponentially, which also kind of means that the IT risks are growing exponentially. So for insurances, this is really interesting and exciting terrain. I said that in theory, insurances could have a bundling effect and as such improve the design process for products. Unfortunately, there's a beautiful quote by a guy called Viktor Chernomyrdin in the aftermath of the Soviet Union collapse, which says, "We wanted to do better, but it turned out as always," which means that it is likely that what I just said cyber insurance could in theory do is perhaps unlikely to happen. What I suspect may happen is that insurances will mandate some checkboxing, like you have to have product category X and Y deployed, and that the actual risk evaluation of the insurances becomes a little bit of a cargo cult exercise where, well, checkboxes are ticked and that's about it. And the biggest worry I have is that cyber insurance becomes yet another product category in this portfolio purchase strategy where we'll just buy one of each. We shall see where this goes. It's definitely interesting to watch. Anyhow, so I've spoken a little bit about what's the perspective of the enterprise and the CISO and why can't we have nice things from their side. I'll shift focus now a little bit and talk about the software supplier side and what I perceive are the differences in ability to understand IT risk between vendors that manage to ship secure software and vendors that don't manage to ship secure software. And well, I guess how should you manage risk for software until more defendable products come along? An important thing to realize is that all code, every line of code that anybody is writing, has a tail risk of blowing up disastrously. And at the moment, everybody writes code and doesn't account for this tail risk. And that's what gets us into trouble again and again. So one thing I sometimes see on the defensive side is there's a bit of a defeatist attitude, like whatever we'll do, we'll always have many, many bugs. And I don't think that's actually true. People sometimes claim as if it was impossible to write reasonably secure software, but that's not actually true. We have several examples of software that we rely on and that has had 0 to perhaps 1 or 2 security issues in a period of 10, 15 years. And the 2 examples here would be OpenSSH and Qmail. So an important question becomes, what distinguishes the pieces of software that we can buy that actually reliably provide security to us and don't blow up on us all the time from those that do? And it can be summed up in good risk management. Dan Bernstein wrote an article in 2007 and it was titled, Some Thoughts on Security After 10 Years of Qmail. And he labeled his 3 principles for keeping stuff secure. And he said, eliminate bugs, eliminate code, and then eliminate trusted code. And they're actually really good pieces of advice. And Qmail has had no remote issues in, I guess it's 2017 now, 20 years. That's fairly stellar. So the big difference that distinguishes people that understand or that end up writing more secure systems from those that don't is the concept of attack surface and the value of attack surface reduction in order to make things actually more secure. Attack surface reduction is the same as complexity reduction in a way. So every line of code running anywhere on your infrastructure is inherently a risk, has a very small tail risk of blowing up disastrously in your face. So reducing the amount of code running is pretty much the only reliable way we know of reducing software risk. Just have less code. And this is where having chats with people in finance comes in helpful for me. I started thinking about IT infrastructures as a form of balance sheet, meaning you have this big IT infrastructure, And this IT infrastructure provides day-to-day benefits to you. That's a bit like a balance sheet where you've got a whole bunch of securities on the balance sheet that provide daily payments or some sort of benefit to you. But each component of your IT infrastructure has a tail risk of blowing up into your face and becoming a big liability. And it seems that at the moment, very few people that look at software in terms of a balance sheet of risks that you have to kind of manage and mitigate. So it's important to realize that when you install software, when you install third-party software, you are taking risks onto your balance sheet. Like if I install a piece of software on my computer, I am taking on all the risks that they have put into their software onto my computer. Adding a line of code to software that I sell means adding risk to everybody's computer, like to the computer of everybody that is running my stuff. And the bizarre thing is, if you look at where security bugs are actually hiding, the vast majority of security issues are found in the less well-trodden path of software, meaning in bits of the software that are not actually used very often. So we have this bizarre situation where 90% of our security issues come from bits of code that provide less than 10% of the benefits. And from a balance sheet perspective, that's just kind of ridiculous. That's like having a balance sheet where something that doesn't actually provide all that much value blows up on you at regular intervals, yet you still have to have it. Now, these numbers are guesses based on anecdotal evidence. They're not actual numbers. Okay, so if we look at software as a balance sheet, a software consists of many components and of many features, and each feature provides some benefit and has some catastrophic tail risk. And the catastrophic tail risk is something that nobody takes into account in current software development practice, or not nobody, but very few people properly take into account when they develop software. And there's nobody to track the risk either. So what we end up with is software that is full of low benefit features that at the same time expose us to a lot of risk. And that's not great. Another thing is that we build organizations in a way that we don't incentivize reduction in complexity. What gets people promoted, and I know this all too well because I'm working in a very big organization now, is adding features and complexity. Like nobody ever gets promoted for saying, I deleted 800 lines of code that would have developed into security issues two years down the line. But if you think about this with the analogy to finance and balance sheets, that's like promoting the guy that takes the most hard-to-value, risky derivatives onto your balance sheet. That just does not sound like a very clever idea. So it's usually really easy in most organizations to find somebody that adds layers of complexity and that wants to add yet another thing to something. People get promoted for shipping features, people get promoted for having built a new system, and so forth. It's very, very difficult to find anybody that volunteers for deleting stuff or for removing layers of craft. And even then, it's not something that organizations in general reward. And it's also not easy. I don't know. It's a good question to ask yourself. Does your organization reward people that remove stuff? I used to joke that the best developer has negative numbers of lines of code per day, which means the best developer takes a piece of software and deletes half of it and still does the same stuff. Okay, now if we understand code and lines of code as exposure, and if we understand code components and features as risk, we need to start thinking about hedging in the sense that if I'm in finance and I have a balance sheet full of complicated things that can blow up on me, I try to limit my risk somehow, and in finance they do hedging. You can argue that having a tight sandbox around risky pieces of software is a form of hedging, which means it may not deterministically protect me against all vulnerabilities, but most likely when that particular component blows up, the risk of that particular component will be isolated. And there's many options through which you can, well, reduce the exposure from a particular software component. There's the Chrome sandbox, for example, which they've open sourced. You've got the seccomp strict sandbox in Linux, which literally disables all system calls except the read, write, and exit. And I have to admit that I know a lot of people that are really good at exploiting stuff. I think the general consensus amongst all of us is we wouldn't know how to get out of a seccomp strict sandbox in Linux, just because the attack surface that you can still reach from there is essentially nil. There's zero VM, there's virtualization solutions. What I'm just wanting to, or what I want to say is there are ways of managing risk from legacy software. They're just not being used. So even if you sandbox your stuff, the sandbox may still contain a security issue. But that doesn't mean that it doesn't provide a lot of, well, protection. Think of it as an imperfect hedge. As I said, it may not always protect you, but it is likely when something blows up in your face to provide some sort of isolation. Now, this has always been a little bit abstract. How do you, in practice, go to a software vendor and apply reasonable risk management to your purchasing decisions? And I wrote a blog post in 2015 which I titled Decision Maker's Guide to Buying Security Appliances. A little bit of background, I was super annoyed with a few security appliances I looked at the time because they were all being shit to their customers in the sense that they were all exposing a lot of really highly privileged stuff to the outside and not telling their customers and not following basic sanity. The sad reality is that this list is still current 2 years later. And so just a list of 5 simple questions to ask whoever is trying to sell you a security appliance. And the first question is, what third-party libraries does your appliance expose to the attackers? And what are the processes you have for dealing with a security vulnerability being found in this third-party library? The background for this is you won't believe how often you take a random piece of software and you just look at the list of open source libraries they use, and then you look at the versions of the open source libraries they use, and you don't even have to look at the project or at the product further to find security issues. You just go and see, hey, this library had a security issue 3 years ago. They took the source code 5 years ago and haven't updated it since. So the translation to finance of this question is, do you as a vendor even know what third-party risks you're exposing me to? Do you have any idea about this? Second question, are any of these third-party libraries that you're using sandboxed? Are there any not sandboxed? If so, why? And what's the timeline to address this? Which means you're asking me to buy your product, so you're asking me to take on this risk. Which parts of that risk are unhedged, and why haven't you hedged them, and until when will you hedge them? So the third question is, how much proprietary code, how much of your code interacts with the incoming data and which runs in a non-sandboxed environment? And to what extent has this stuff been security reviewed? The translation to finance is, how much of your dealings will expose me to risk? Is any of this unhedged? And has anyone who knows something about accounting and risk ever looked at it? Doesn't seem like a very rude question to ask either, but vendors will not always be happy. Question number 4. Will the vendor provide a hard disk image of the appliance to go for a basic security review by a third party? Translation to finance, you're asking us to take on this balance sheet full of risks. Can we have an auditor look at it, please? Which also shouldn't be difficult. And lastly, in case of a breach, is there any infrastructure or are there any processes through which a forensics team can investigate what happened on the device? So in essence, just when disaster happens and I get hacked, is there any way for me to investigate whether the appliance I bought from you was part of this attack? Right, so the sad reality is that almost no security appliance vendor will be able to answer these 5 questions satisfactorily, which in my opinion means we're not asking them enough. At the moment, a lot of vendors get away with just pushing the shiny product on people, showing them a shiny PDF brochure about what the product allegedly does, and, well, then showing the management interface, and that's about it. And I think we all like to complain about broken products, but to a certain extent, by the buying side not asking enough of the right questions, we're encouraging, subpar behavior on the side of the vendors. So none of these questions are unreasonable. I think all of them are quite focused and not crazy. Almost nobody answers them correctly. So customers of software and customers of devices need to treat deployment of stuff as taking on risk much more. Because at the moment, we're just deploying stuff without thinking about the risk at all. Doesn't mean you can't deploy, it just means like when you take on risk, be sure that it provides a benefit and be sure that you hedge your exposure somehow. So is it all gloom and doom? People tell me that my talks are often a little bit depressing. So it is not all doom and gloom. I mean, the positive things to take away is secure software can be written. We have examples where it works. Risk can be reduced significantly. We have examples where risk gets reduced properly. The issue is that risks grow because we're not thinking of them as risks. We're thinking of them as something that provides a marginal benefit at zero cost, when in fact it provides a marginal benefit at zero cost now, but potentially high cost in a rare situation. And in theory, we have all the tools to reduce the risk posed by legacy code much more through sandboxing and other means. It's just we're not doing it. And lastly, all of this will not give us perfect security. But the easiest wins at this moment, from my perspective, is just taking all this garbage code that we've got running everywhere at high privilege and asking, is there a way to lock it in tightly so it can't blow up on us? Anyhow, the incentive structures that are currently poisonous can be broken. Well, they are broken. I'm confused about the slide. Rewind 20 seconds. Summary. The incentive structures in IT purchasing are broken at the moment. Oftentimes the customers are fragmented, don't have enough market power, are often at an information disadvantage, like they can't actually judge the quality of the products very well. Way too few people understand the equivalence between code and risk well enough, or treat it as such. And very few people understand the equivalence or the analogy between sandboxing and hedging enough. Sandboxing and reducing privilege may be the most underused technology we have available these days. Fixing it is difficult, as everything worth doing. We need to start recognizing the role of incentive structures in organizations much more. Like, we need to actually try to incentivize people to reduce our exposure. Like, pay somebody to reduce the amount of code in something. Pay somebody to sandbox stuff, and so forth. We need to shape incentive structures more and more actively, which also means we need to tell vendors what we need, and we need to, insist that they answer our questions. In theory, the cyber insurance business could play a good role in shaping the incentives by centralizing purchasing power. We shall see how that works. The other thing that really needs to change is people need to think about risk and taking on risk much more. Anyhow, thank you. For a question? Yes, please.
Should I speak to the microphone or should I?
Just yell, I guess.
All right, so thank you for the thought. You mentioned that the incentives are broken, and do you think the government regulation should play some role in fixing it? Do you think the market can provide it?
So this is an interesting question. The question is, if the incentives are broken, do I think that the government can help fixing the incentives in a way by regulation? And that's a complicated one. So I think in theory, the government could help with regulation. The practice is that regulation by government, like I've seen this with Wassenaar, where good intent mutates through the political process into something that is horrendously broken at the end of it. So I guess my argument is that well thought out, carefully considered regulation that can be changed quickly when we see it's going wrong could play a positive role. But I'm not sure whether that's not harder to achieve than other means of fixing the incentives. Does that make sense? Yes, please.
You mentioned about cyber insurance.
Yes.
Is there any instance where they have actually paid out a security organization when a breach occurs?
So
in other words, no, thank you. In other words, how would a cyber insurer be able to evaluate that the organization has indeed taken the necessary controls or the remediation measures in place before granting our insurance?
Right. So the question is, do I know of any instance where cyber insurance has actually paid out to a security organization in case of a breach? And the second part of the question was, how does the insurance ensure that the enterprise actually held up their side of the deal and well-performed due diligence or proper security controls. So there have been cases where cyber insurance has paid out in situations like ransomware, where people have been insuring themselves against ransomware, and then the insurance pays for the ransomware payment to get something unlocked. At the moment, the insurances are, they write these policies very much for every customer individually, and then the legal departments on both sides haggle. But there have been instances where money has been paid out, so that has happened. The other side is, on the topic of how do insurances ensure that the other side is holding up their part of the deal, I think the insurances are still learning this at the moment. This is what I meant with, they don't quite know what to ask of their customers, and if things go bad, it'll be a silly checklist. If things go good, it'll actually be reasonable requirements. It seems to me like a learning process. I haven't actually seen two insurances that have the same requirements. I know that on a non-cyber insurance side, we used to have a corporate liability insurance for the small company I was running, and the corporate liability insurance mandated we run antivirus on every machine, which in our case meant we installed ClamAV and put it in a folder somewhere where it can't do any damage. But we did need to satisfy the requirements of having an antivirus installed on every machine. Well, thank you.